Okay, complex fractions. Here's the big thing. Here's the one big difference from complex fractions that we did from all the other fractions 8.5. You are still going to find the least common denominator. And once you find the LCD, the next step that you have to do is you've got to take and multiply all the terms. Okay, so after you've got the least common denominator, multiply all the terms by the LCD. Alright, and once you've done that, it basically should be that you're going to have a less complex fraction. Now you're going to have just a normal fraction. And from there, kind of like we did in the other parts, look at what you have left over and then simplify and factor if it's possible. Okay, so that's the biggest difference, and this is where this is going to tie in with 8.6, because once we do this example, it's going to walk us in, and we're going to do basically the same thing for the complex fractions that we're going to do when we're solving in 8.6, that you're going to multiply all the terms by the least common denominator. Yesterday we had to find the least common denominator and rewrite it. This part is actually a little bit easier because you're not rewriting anything, you're just multiplying stuff, and when you do that, you're going to start canceling stuff out anyway. So, alright, so let's give you a couple examples. Just so you can see what we're kind of looking at here. So example 1, we're going to do with x over 1 over x plus 1 over y. What makes it complex is that you've got a fraction inside a fraction. That you've got the top part you've got x, the bottom part you've got 1 over x, and you've got 1 over y. So that's what complex fractions are going to look like, that you've got a fraction inside a fraction. Just makes it that much more complex. Okay, now, and when you're doing these, the least common denominator for the complex fractions should be really easy because they're not going to make it real complicated. So all you're going to do is just tell me everything that's in your denominator. Down here, you've got 1 over x and you've got 1 over y. So your least common denominator is going to be xy. And the good thing about the complex fractions that we're going to do, it should be really easy to find the least common denominator. We're not going to have to do like we were doing yesterday. So then what we're going to do is we're going to take that x times y and multiply it times every single thing that's up here. It depends on what you have in your denominator. Okay, so we're going to multiply every single term by xy. So you've got 3 different terms here. You've got x, 1 over x, 1 over y. So we're going to multiply all 3 terms by x over y, or x times y. And what should happen is, when you do that, you should go from just having the fraction inside a fraction, that now you should only have just a numerator and a denominator that's left over. You won't have this double fraction thing that's going on here. So if you do x times x, that's x squared. And then the y is there. And for this one, when you multiply these together, the x's will cancel each other out. That's going to leave you with a y. This one, the y's will cancel each other out and leave you with x. And if it helps from these, when you're thinking about multiplying these out, again, you can put these over 1, just so you know that x, y is in the numerator and the 1 would basically be your denominator there. That's a terrible looking y. It looks more like a 4. So x squared y is over y plus x. And again, technically, when you start adding and subtracting, those two things are in parentheses. So that would be your final answer. Okay, so for that part of it, finding the least common denominator, yesterday was a lot of work because we had to go through and we had to factor and do all kinds of different things. For the complex fractions, these should be really simple to find the least common denominator because it should just be you're just looking at the denominators and tell me all the different denominators that you have. So this part actually, even though it's the complex fractions, it actually is a little bit easier than the other fractions. All right, so let's do one more of those. All right, so for example 2, we'll go x minus 2 over 3 plus 2 over x minus 1. 3 over x plus 1 and then minus, hard to see it there, but that is a minus, minus 1 over x plus 1. Actually, we'll make one small change. That's an x plus 1 right there. Okay, and here's where you can kind of take it apart a little bit, a piece at a time. If you look at just the top part, look at the numerator. What's in your denominators up there in the top? So you got 3 and x plus 1. And on the bottom, just x plus 1, right? So for that part of it, you've got your least common denominator right there. It's just 3 and then x plus 1, because that's the only thing that's in the denominator. So that, again, that part should be a lot easier than what we were doing yesterday, because yesterday we had to do a lot of work to find the least common denominator. For the complex fractions, it's really pretty simple. Just tell me everything that's in your denominators. Anything that's different, put that in there. Okay, and here's the longest part of it, because now we're going to take every single thing that's here and multiply it times 3 times x plus 1. Okay, so just rewriting that problem takes the longest amount of time because you've got to go back and rewrite the original problem. And again, every single thing that's in there, you've got to go back and multiply times 3 times x plus 1. Oh, it is. Thank you. It is an x plus 1. And again, the whole reason that you do this is that once you get finished, all the fractions should cancel out and you should have just a regular numerator and just a regular denominator. So for this one, the 3's will cancel here. The x plus 1 will cancel that x plus 1. That x plus 1 will cancel that x plus 1, and that x plus 1 will cancel that x plus 1. And from there, just write down everything we have left over. So now you've got x plus 1 times x minus 2 plus 2 times 3. Alright, and on the bottom we've got 3 times 3 minus 1 times 3. Yeah, and that's the whole thing you're trying to do with the complex fractions is that when you multiply everything by the least common denominator, now you've got just a regular set of numbers on top, and then you've got just a regular set of numbers on the bottom. And from there, just work it out. Now the bottom's going to be a little bit easier because the bottom, 3 times 3 is 9. 9 minus 3 is 6. So the bottom part's just 6. top part, that's the part we got to work on because there's a little bit more stuff in the top part. Which one? This right here? Or this? That right here. Oh, because that 3 is on top. If you put that over 1, that 3 is on top and that 3 is on top. And the only way you can cancel is one's got to be on top and one's got to be on bottom. Okay. Yeah, and again, for those, could have gone back and put those over 1 so you can kind of keep place of which one's in the top and which one's in the bottom. Okay, so for this part, now you do have x plus 1 times x minus 2, so that one you are going to have to do the full method. So if we do the full method, you've got x times x for x squared. X times negative 2 for a negative 2x plus 1x. 1 times negative 2 is a negative 2. Okay, this part's really easy. 2 times 3, that's just a 6. And I couldn't make all that fit here, so I just went ahead and just dropped it down here. Okay, and on the top part, for once you've done all the everything on the top part, we know the bottom part is going to be 6, so that part we already have it. We're just working on the top part now. So you've got x squared. We've got a negative 2x plus 1x, that's a negative 1x, or just a negative x. And then a negative 2 plus 6 is a positive 4. And if you start checking everything, there's no factors of 4 that's going to get you to 1, because it's either 1 and 4 or it's 2 and 2. There's no way you can add and subtract 1 and 4 and get 1. Same thing with 2 and 2. There's nothing you can add and subtract with 2 and 2 to make it out to be 1. So for that one, that would finally be the last thing that we're looking for. So the whole thing you're trying to do with complex fractions is you're going to start with something that's got multiple numerators and multiple denominators, or just a lot of different parts here. And eventually you're going to get it down to where it's just a regular fraction. We got just one numerator and one denominator. And that's the whole thing that we're trying to look for there. Okay, so even though it's complex fractions, they're actually easier. To me, they're easier than the other part because you don't have to rewrite anything. You don't have to do all the factoring. This one is pretty much, here's the denominators that you have. List off the individual ones, tell me all that's there, and just go back and multiply. And it's more canceling than it is anything else. There's a little bit of work to it, but for the most part, it's just a little bit simplified. Okay, so that was the last piece of 8.5, and again, we kind of wanted to wait for that one for today because the next thing we're going to do in 8.6 is we're going to take the same thoughts we had here, but we're going to add that to 8.6. And if you want to put this right behind 8.5 that we just got finished, that's fine because these two almost go together because you almost do the exact same thing for complex fractions that you're going to do for solving rational equations. A couple of little things different, but for the big idea of it is it's all basically the same thing here. Okay, and when you're solving equations, this is where it's going to be kind of like what we're doing back in 8.4. The very first thing you're going to have to do is you're going to have to tell me what's the excluded values. You're going to have to tell me what the restrictions are. And again, they kind of go back and forth on those. I think they wind up using the word restrictions more than they do excluded values. But you're still going to do the same thing we were doing back in 8.4. You're going to tell me what the excluded values are. After we've done the excluded values, you're going to multiply all the terms by the least common denominator. And that's the same thing we're doing back in, for these examples up here, that once we find the least common denominator, we'll multiply all the terms. So that's why these two things are similar, and that's why they go together so much. And then the last thing you're going to do is you're going to solve whatever equation you have left over. Now, in some of the solving problems, it's going to be kind of easy. Some of the solving problems, when you get to that last step, you might actually have to do some more factoring like we were doing back in section 4. So this one, 8.6 really almost goes with 8.4 because it's almost exactly the same thing. That you're still going to state the excluded value. You're going to solve whatever equation you have, but the only thing we're going to do is that we're going to tie in 8.5 is that you have to find the least common denominator. Okay, and then I almost would say step 4. And this is just an extra little thing you have to do, because sometimes you'll get here and you'll be finished and you think you've got the answer, and then you've got to go back and do this part. Last little thing, just check to make sure your answer, or your answers, whichever one you get there, exclude values. Okay, so everybody that wasn't here Monday and Tuesday, this is kind of a good review, because basically the first thing up here when we're stating excluded values, that was the big thing we did on Monday. Multiplying all the terms by the least common denominator, or finding the least common denominator, that's what we did yesterday. And then multiplying all the terms by that least common denominator, that was the part we just kind of did back in the back end of section 5 there. So 8.6 is really a good review of everything we've done in 8.4 and 8.5. So if you weren't here Monday, Tuesday when we did this, then you're kind of getting a good crash course on everything that went on here. Let's go with x over x minus 3 plus x over x plus 3. And let's that equal 2 over x squared minus 9. Okay, so all the band people and all the other people that weren't here Monday, here's how we're going to do restrictions. That for the restrictions, or the excluded values, you've got to take every single denominator that's here and set each of those equal to 0. And whatever you get for those answers when you set those pieces equal to 0, that's going to be your excluded values. Now, some of the problems with it, like this one, this is going to be easy because you're going to add 3 over here. So you're going to exclude x equals 3. This one you would subtract 3 from both sides, so that would be x equals negative 3. For x squared minus 9, that denominator is a little bit more complicated because you start with x squared, you've got to do some factoring on it. The good thing is when you factor this one, that's the difference of 2 perfect squares, and that would be x minus 3 and x plus 3. And you've already set both of those two things equal to 0, so if you set those equal to 0, you've got the exact same answers again. Okay, so we're excluding x equals 3, x equals negative 3, and we're just repeating it here, so basically we're just excluding 3 and negative 3. So that's the answers you cannot have. If you get 3 or negative 3 and you plug those answers back in, it makes your denominator 0, which makes this thing undefined, which means it doesn't work. It's an answer that doesn't fit. And it goes back to our question of, we could get rid of 99% of traffic fatalities. Speed limit's 10, right? But that doesn't work. I mean, that's just not going to work. So same thing with this one. If you get either one of those two answers, even though they may show up and they're answered, they're just not going to work for the situation that we're in. Okay, so there's the first thing is we've got our excluded value. The good thing is now to do the least common denominator. How many different things did we have when we started factoring? When we set these denominators off equal to 0, how many different things did we have there? How many different expressions? We got an x minus 3, and an x plus 3, and an x plus 3, and an x minus 3. So our least common denominator would just be that. It's an x plus 3 and an x minus 3. Because that's the only thing that's in our denominator. And then here's where we're going to borrow the thing we just did with the complex fractions. We're going to take these denominators that we have, or the original problem, and we're going to multiply it by our least common denominator. Again, if you're going to put that over 1 just so we can see how it's going to cancel, we can do it there. Plus x over x plus 3 times our least common denominator. Now, even though that's x squared minus 9, we factor that off as x plus 3 and x minus 3. So when you write this one, I would say let's write it as that. Let's write it as x plus 3 and x minus 3. And then we've got to squeeze in that x minus 3 and that x plus 3. Okay, so these problems do get a little bit long because of just the fact that you've got to write a bunch of stuff in there. Okay, and just like the last problem, when you do this, denominator-wise, all the denominators should be gone because this x minus 3 will cancel that x minus 3. That x plus 3 will cancel that x plus 3. Again, we'll put those over 1, just kind of hold them in place. That x plus 3 will cancel that x minus 3. And that x plus 3 will cancel that x plus 3. And when you get finished, there shouldn't be any fractions at all left over. It should just all be whole numbers. You've got an x plus 3 times x here. We've got a plus an x here and an x minus 3 there. Equals, we've got 2 times nothing else, right? I mean, we've got 2 over 1, but if it's 2 over 1, we can just make that 2. So once we multiplied and got rid of all the fractions, now we've got something that doesn't look quite so bad. The last thing is here, we've got to do some distributive property. So we've got x plus 3 times x, so if we do x times x, that's x squared. X times 3 for 3x. X times x for another x squared. X times negative 3 for a negative 3x. That's going to equal 2. Okay, and all this stuff on the left-hand side, we've got to combine some like terms. Now, here's one where you got to be a little bit careful. When you add the x squareds together, remember that is 1x squared plus 1x squared. So that would be 2x squared. 3x minus 3x makes that 0x, which means it's gone, equals 2. And here's where we got to have a good memory. Going back before fall break. If you had 2x squared equals 2, we got a couple options we can do here. What's one option we can do for this thing? Divide both sides by 2. Let's go with that one first. I think that's probably the best. And again, you've got a couple options, but I think that's the best bet. Let's divide both sides by 2. So we want the x squared all by itself. So we've got x squared equals 1. Everybody remember how to get it down now? There we go. Square root both sides. Because if you've got just x squared equals some number, you can just square root both sides And when we do that, we get x is going to equal square root of 1 is 1. And remember, because it's x squared, we need two answers, right? So we need a positive 1 and a negative 1. Okay. A lot of work to get there. Finally got. Now, the last thing is, and sometimes this is where it's kind of easy to forget. You've got these answers, and the one thing you have to kind of do is you have to flash back up here to the beginning. We had to get rid of the answers of 3 and negative 3. Our answers were positive and negative 1, so those answers are okay, so that's our final answers there. If we had x equals 3, if we'd done some factoring and got an answer of x equals 3, we'd have had to chunk that answer out because that says you cannot use that answer. So if we had gotten x equals 3, you just had to chunk it. But we didn't, so we're okay. Alright, let's get you one more of those. One more kind of big one, and then we've got two small ones, and then we'll wrap this thing up. Okay, so very first thing is, once we've got this one, we've got to figure out what our excluded values are. And again, this is kind of it's two parts. When we do the excluded values, we're also going to find the least common denominator. So at the same time, we're doing basically two steps in one here. We're going to exclude all the denominators equal to 0. This one's pretty easy. Just change that by subtracting 2 on both sides. This one you subtract 1 on both sides. And this one you do have to factor it off. But the good thing is, you're factoring 2. There's only one way to factor 2. It's got to be 1 times 2. It's all positive, so that means that they're all positive. And you don't really have to set these equal to 0 because we've already done x plus 1 equal to 0 here. We've already done x plus 2 equal to 0 here, so we could keep going, but we've got everything we need right there. So we're going to exclude negative 2 and negative 1. So if we did keep going there, we'd get the exact same thing we already had here. So that's one of those cases where they kind of doubled up the denominators there. You just had to factor it just to make sure that there wasn't anything different in here. Okay, now when you got your exclusions, you're also going to have your least common denominator. Because your least common denominator is, all right, how many different things did you have down here that you factored out? We had x plus 1, x plus 2, x plus 2, and x plus 1. So all we had was x plus 1s and x plus 2s. So that's going to be your least common denominator because that's everything that's in your denominator. So anything at all that shows up on this list when you start factoring them off and set them equal to 0, anything that shows up, that's going to be in your least common denominator. The good thing is we only had 2. We had an x plus 1 and an x plus 2. Alright, so now we're going to go back. Now again, we factored this one off as x plus 1 and x plus 2, so let's rewrite it that way. And we're going to take every single thing here and go back and multiply it by x plus 1 and x plus 2. Again, if you want to put that over 1 just to kind of hold it so we know that x plus 1 and x plus 2 is in the numerator, we can do that. Okay, so original problem in blue, least common denominator in red, and we're going to multiply that least common denominator by every single thing that we had in the original problem. Okay, and again, when you're solving equations, all the fractions should be gone. If they're not, then you did something wrong. So that way, you know, you may have missed the least common denominator, or you may have just forgot to cancel something. So this x plus 1 is going to knock out that x plus 1. That x plus 2 will knock out that x plus 2. That x plus 2 will get rid of that one. And that x plus 1 will get rid of that one. Okay. And again, all the fractions should be gone, so it should just be whole numbers left over. You've got an x plus 1 here. Sorry, an x minus 1 there. We didn't have anything else, so we didn't really need the parentheses there. Just kind of force of habit, put that one in there. But we'll take them out here in a second. This one, you've got 2x times x plus 1. And this one, you've got an x minus 1 and an x plus 2. Okay, nothing you can do here, so we'll just leave that one like it is. This one, you've got to do 2x times x, so it's a 2x squared, and then 2x times 1 for a 2x. And on the right-hand side, we are going to have to do the full method there. So if we do that, you get x squared plus 2x minus 1x minus 2. Okay, so over here you can put those two together. If you do 2 minus 1, that's a 1x. If you want to put the 1x, or you can just leave it as x, that's fine. Left-hand side, we've got a little bit more stuff to do. You've got the 2x squared, which is all by itself. You do have a 1x plus 2x over here, so go ahead and add the 1x and 2x together and make that 3x. And then that minus 1 is just trailing behind the end of it there. Okay, so now we've got stuff scattered everywhere. So we've got to get some stuff in the, got to get some of the terms in the same places. Since we've got an x squared over here and x squared over here, let's get rid of this x squared that's here and let's move it over here. So they'll leave x squared equals x plus, or x minus 2. Alright, let's get rid of the 1x that's here. X squared plus 2x minus 1 would equal negative 2. And then last thing is we need to add 2 to both sides. Okay, so we didn't, in the earlier problem, you may be saying, why did we do that? Because earlier problem we just had x squared and a number. If you've got just x squared and just a number, you can separate those two, but if you've got this extra x, that's when you got to pull it all together on one side. Okay, so we've got x squared plus 2x plus 1. So we're looking for two answers, right? Because we have x squared. What's the only factors of 1? 1 times 1, right? And 1 plus 1 is 2, so basically when we factor this thing off, we've got an x plus 1 and an x plus 1. Set those equal to 0, and we get x equals negative 1. And again, you could say, well, you know, I thought we needed two answers. Well, technically you're setting that parentheses equal to 0 also. So the two answers are negative 1 and negative 1. It's a repeat answer, so that's why it's kind of showing up twice. If it shows up twice, you really only have to put it once, because you don't have to put it twice. Now, here's the last thing you got to do, and sometimes this one sneaks value. Our excluded values were -2 and -1, right? So we cannot use -1, so that answer's out. So we had one answer, but we said we couldn't use it, so now if we can't use the one answer that we were given, that answer is going to be no solution. Yeah. Now, most of the time, usually, you may not always get it that way, but usually there is one answer. Sometimes it's not going to work. Most of the time, you'll get one answer that works and one answer that doesn't. Just want to show you this one because if it does happen that either one answer is gone or both answers are gone, then no solution is a possibility. It doesn't happen a lot, but it is a possibility that there may not be a solution that works at all. All right, last two questions. And these will go a whole lot faster than what we did here. Everybody good, or we need to pause for just a second? All right, we need to pause. All right. Last two examples, and these go a lot faster than the other examples here. This one, show you this one because it's a little bit different problem. Because sometimes you get to the easy problems and you go, well, wait a minute, whoa, what am I doing? This is not anything like the other stuff we're doing. So here's one that it's an actually easier problem. Just want to show it to you because sometimes when you get the easy problems, you try to make them hard, and there's really not much to make hard here. All right, first thing is, if there are no letters in your denominator, or no variables, because we don't have any for this one. If there are no variables in your denominator, that means you have no exclusions. So for this one, there are no excluded values. There's no restrictions because your denominators are 3 and 5. That never changes. So that part, you don't have to worry about any restrictions on this kind of a problem. So now we're just doing the LCD. So what's the least common denominator of 3 and 5? Well, if it's the two numbers, you just multiply them together, right? 3 times 5 is 15. There you go. So, no restrictions. We've got our least common denominator, so now we're going to take every single problem up here and multiply it by 15. All right, again, when you do this, everything should cancel. How many times will 3 go into 15? 5 times, right? So that leaves you with 5 times y, or just 5y. How many times will 5 go into 15? 3 times. So that leaves you with 3 times y, or just 3y. Okay, now the one thing you have to remember, sometimes, it sounds like the biggest mistake on this is, at the end, sometimes people forget to multiply the whole number times 15. That if you multiplied everything on the left by 15, you still need to multiply everything on the right by 15. So multiply 8 times 15 to make it 120. So you have 8y equals 120. Take 120 and divide it by 8. And then y would equal 15. Oh, sorry, slide up there. Okay, so that's one where it's still solving equations with the rational expression. It's just a little different because the denominators are really pretty easy. So if you got just the numbers there, it makes getting the least common denominator really easy. And again, that's one just to show you, just because sometimes the easy problems will sneak up on you and you kind of hit a roadblock because you're trying to make it hard. That's one where it's not really all that hard. All right, last problem. And this is a word problem. I know how much I love word problems. But if you get this one, then on the test, it should come at you pretty easy here. All right, I need 2 volunteers. Who's my volunteers? All right, we got Dallas and Brooke. All right. All right, Dallas and Brooke. They have a take-home test. Brooke says she thinks she can do it in let's say 5 hours. Well, Brooke can do the test. In 5 hours. Dallas says, well, I get a little distracted sometimes and I don't always pay attention, so it's going to take me about 7 hours to do it. So one of them can spend 5 hours doing the test, the other one can do 7 hours. The question is, if they work together, how long will it take? Now, you're going to share the test, though. So this is where you can kind of split it up and figure out what it's going to do. Now, Brooke can do it by herself in 5, right? So if Dallas starts to help out, it's going to be less than 5, right? Because he can take some of the problems from Brooke and do some problems along the way. So we've got to figure out what that's going to be.
May I have your attention, please? Teachers, please refer to the email sent by Mrs. McCants and send only those students listed to take the PSAT to the cafeteria at this time. Students should bring their things with them. Please only send students that are listed. Thank you.
All right, so here's what you're going to do. Whatever the 2 numbers are here, you're going to put one of those numbers over 5, because one of them was in 5 hours. The other one was in 7 hours. You're going to put that over 7. And together, they're going to take one test, right? So we're going to let that equal 1. And that way, now that you've got this set up, it's exactly like the same problem that we had before. Now we're just going to find the least common denominator, which is just 5 times 7, 35. And we're going to multiply all the terms by 35. So 35 times x over 5 plus 35 times x over 7 equals 35 times 1. Okay. And again, everything should cancel. It should just be whole numbers. 5 will go into 35 7 times. 7 will go into 35 5 times. So we've got 7x plus 5x equals 35. That's 12x equals 35. Now, 35, if you divide 12 into 35, it doesn't go evenly. So this is one where they would have to tell you you'd have to round the answer off. If you take and divide 35 by 12, that's about, it's almost 3, so we'll say it's about 2.9. So for them, if they do it together, they can do it in almost a little less than 3 hours. So about 2.9 hours.